Let's look at a general strategy for solving equations. We've looked at 5 types so far: linear, quadratic, rational, radical, and absolute value equations. Any one of these could come up in a problem in college algebra or in calculus. So it's important we know what to do when we get one of them. A good strategy is to know 2 things. First off, how to recognize what type of equation you're working with, and the second is what's the first step or the first goal for that type of an equation. Let's do that for these 5 types, emphasizing those 2 things. So a linear equation is an equation in which the variable is raised to the first power, no more. So for instance, we have a 2x term, and we have a constant term. We also have a 3x term. We have some multiplication through distribution, but we don't have an x squared or an x cubed. And these are the simplest type of equation we can come up with. Basically, we just want to simplify each side and then isolate the variable. Quadratics are the next step up. A quadratic is going to have a squared variable in it, so an x squared term. If you have an x squared in your equation, generally you want to get 0 on one side because 2 of your techniques for solving quadratics, factoring in the quadratic formula, require that you look at the information with 0 on one side. If there's no bx term, you can consider using the square root method because it's really quick and handy. After that, the last 3, rational, radical, and absolute value equations, it's all about dealing with a single step to get us back to one of the other 2 types. So let's take a look at them one by one and think about what that first step or goal would be. Rational equations are going to be equations that have fractions with the variable in the denominator. It has a fraction. We don't want fractions, so the very first step is going to be to clear the fractions or clear the denominators out of there by multiplying by the LCD. So rational equations have fractions, so get rid of the fractions. Radical equations have roots. Because they have roots, that's what we want to get rid of. To get rid of the root, we isolate the root and then raise each side to the appropriate power. So a radical equation has a root, get rid of the root. The absolute value equation is an equation where the variable is inside an absolute value. We want to, similar to the root equations, isolate the absolute value, and then what's different about the absolute value equation is we're going to split into 2 equations, where once we have the absolute value isolated, the inside of the absolute value is going to be equal to the positive and the negative result of that absolute value is equal to. So we will split into 2 simpler equations and solve them both independently. So understanding what you have in terms of your equation, what type it is, that can help you know what to do first. Here we have 6 equations. We want to solve these equations, but as I said, the first step in terms of a general strategy for solving any type of equation is to identify what type that equation is, and then using that information, decide what you would do first. Figuring out that first step is vital in terms of continuing on with the process and actually getting to a solution. So let's take a look at these 6 equations. We're going to start with the one in the upper left-hand corner and then proceed down. So first I have 1 over x minus 5 plus 4 over x plus 3 equals negative 7 over x squared minus 2x minus 15. Notice I said over a lot because these are a bunch of fractions. And so this equation is a rational equation because it consists of fractions. All right. With rational equations, because they have fractions, we want to get rid of those fractions to make the equation easier to work with. So the first step would be to clear fractions. And how we clear those fractions is that we multiply by the LCD. So with a rational equation, when you see that you have an equation with fractions, clear the fractions as a first step. Okay. To the right, I have my next equation, x times x minus 3 equals 5x plus 10. So initially, when we look at this, there's no fractions, no absolute value, no square roots, so nothing unusual. So then we think, is it linear or is it quadratic? To determine whether it's linear or quadratic, we have to look at the exponents involved with the variables. Right now, it looks like we have x's raised to the first power, but always distribute to make your final judgment. And when we distribute the x on this left-hand side, we get x squared minus 3x equals 5x plus 10. So you can see that x squared popping up. So this makes it a quadratic equation. With quadratic equations, the most common ways to solve them is to use either factoring or the quadratic formula. So in both of those techniques require that you get 0 on one side. So your first step generally in solving a quadratic equation is to get 0 on one side, so that you can either factor the other side, or if factoring doesn't work, you can use the quadratic formula. Continuing on down, our next equation on the left in the middle, 3 times the absolute value of 2x plus 3, stop the absolute value, minus 1 equals 20. So what we have here clearly, as I said it, is an absolute value. And so this is an absolute value equation. To solve an absolute value equation, what we need to do is to get rid of that absolute value. Okay, but you technically can't use our strategy for getting rid of an absolute value unless the absolute value is isolated. So we're going to isolate and then remove the absolute value. So isolate the absolute value, I'll abbreviate absolute value here, and then get rid of it. And when you get rid of it, you're going to split into 2 separate equations. So this one equation becomes 2. And I'm abbreviating equation there. So we're going to isolate the absolute value and then get rid of it by splitting it into 2 equations. So when you know you have an absolute value equation and just look for the absolute value symbols, that's going to be your first strategy. And moving to the right, we have the equation 5 times x minus 4 equals 5 minus 2 times the quantity x plus 1. What we have here appears to be linear because there's no radicals, no absolute value, no fractions, and we don't see any x squared right now. We do have a distribution, so it's always a good idea to distribute and make sure you still don't have any x squared terms. So as I distribute the 5 to the x minus 4, we get 5x minus 20. And if I distribute the negative 2 to x plus 1, I get negative 2x minus 2. Watch your signs whenever you distribute. As you can see, there's still no x squared terms, so this appears to be a linear equation. With a linear equation, you do not need to get 0 on one side like you do on a quadratic. All you need to do is simply isolate x. Now, you may have more than one x term. As we can see, we have 5x and 2x. If you have more than one x term, just move them to the same side and collect like terms. And then you're going to simply isolate x. But there's no need to get 0 on one side if you know you have a linear equation. All right, continuing down and on the left, we have the equation 3x squared minus 5x equals x times x minus 5 plus 24. This equation right off the bat you can see has an x squared. So we suspect that it is a quadratic equation, and it definitely has no fractions, no absolute value, no square roots. So quadratic looks to be the right decision here. Now with quadratic equations, again, first step is generally going to be to get 0 on one side. Now one thing I didn't mention up above when we looked at the other quadratic is that even though our most common strategies are factoring and the quadratic formula, in which case we do want to get 0 on one side to use those, there is another strategy, which is to use the square root method or completing square method. Generally, what I recommend is start by considering that you need to get 0 on one side. And then if you have a special case where, for instance, your x term drops away, you could use the square root technique. It's kind of a shortcut when your x term goes away, when you still just have, when you end up with just a square term and a constant term. Then you could use the square root method to save yourself time. But again, generally, you want to get 0 on one side and use factoring or the quadratic formula. The quadratic formula will work every time, so it's a good strategy to get that 0 on one side once you know you have a quadratic. All right, my last equation, x equals the square root of x plus 8 plus 4. That has a square root in it, so technically we call this a radical equation. Anytime you have a square root, a cube root, a fourth root, any kind of root, that is a quadratic equation as long as the variable is underneath the root. Okay, so technically the variable has to be underneath the root to actually make it a radical equation. So when we have a radical equation, in this case square root equation, what we're going to do is have to isolate the square root first. Just like we had to isolate the absolute value in the absolute value equation, we have to isolate the square root, or the root if there's a different root. Once you've isolated the square root, then you're going to go ahead and square both sides of the equation to get rid of the root. But you have to isolate the square root before you do that. Now, as I mentioned earlier, recognizing what type of equation you have, first step in terms of solving it, because that will lead you to maybe the first thing you should try to do. And often just getting going on a problem is going to kind of get your mind thinking about what to do next. So even if you just know the first step, then that will lead you maybe to thinking about what the second step would be and the third step if you've had enough practice. It gets your mind working on the scenario, and then you just kind of generally progress through. So understanding what am I working with and what's that first step is a huge deal in terms of solving any equation. Next, I'm going to have you solve these equations. So what you might do before watching the next video is actually take some time on the next couple of pages and try solving these based on these first steps we've talked about. And then you can watch the next few videos and actually see if you did the same thing I did. Did you get the same results? I also go through checking each of these equations.